Hi everyone, today we'll be talking about the Pythagorean theorem. So the Pythagorean theorem is a theorem that goes along with right triangles. So first let's review what a right triangle is. A right triangle is a triangle with one 90-degree angle. We usually show that with the little box in one of the corners. So that's the symbol for a right triangle, or for a right angle. Alright, so let's take a look at the anatomy or the parts of a right triangle. These two sides here that both line up against that 90-degree angle, those are called the legs. So a couple things we need to remember about the legs. Okay? They are always adjacent to or next to the right angle. So they're always touching that right angle. Okay? Those are the two sides that come together to form the right angle. And they're also the shorter two sides. Okay? These two are always going to be shorter than this side here. All right, so now let's talk about this side here. The longer side is what we call the hypotenuse. The hypotenuse is always going to be across from that right angle, always. The hypotenuse is always across from the right angle, and it's always going to be your longest side. All right, so now the Pythagorean theorem. What is it? The Pythagorean theorem is a formula that says if we square side A, and then we add that to the square of side B, then it will equal the square of side C. All right, so let's put that to use. We can use this for a couple different things. We can use it, one, to determine a missing side of a right triangle, or we can use it to determine if a triangle is going to be a right triangle. All right, so first let's use it to find a missing side. So here we have two sides given to us, 7 and 2. And they want us to find this side here. Well, the first thing we need to do is identify who's going to be our A, who's our B, and who's our C. Well, remember, we said that our C is always the side across from the right angle. Right? It's always our longest side. So let's identify our C first. Right? It's always the side that's across from our right angle. So this one here is going to be my C. Now when it comes to side A and side B, it doesn't really matter which one is which. Right? You can call this one side A and this side B, or you can call this side A and this side B. It doesn't matter. I just so happen to call this one side A and this one side B. Alright, so now that we have those labeled, we're going to take our formula and we're going to write that down. A squared plus B squared equals C squared. And now we're going to fill in the information that we have. Well, we know that A has a value of 7 and B has a value of 2. So I'm going to plug those into my formula. So now I have 7 squared plus 2 squared equals C squared. All right, so I'm going to evaluate this. So 7 squared, 7 times 7 is 49, and 2 squared, 2 times 2 is 4. So the Pythagorean theorem says that if I add these two numbers up, it will give me the square of this side. So 49 plus 4, whoops, didn't want that yet, gives me 53. All right, now that gives me the C squared, but we want to actually get the value for C itself. So in order to do that, I have to do the opposite of squaring a number, because I have to undo that little 2 there. So the opposite of squaring a number is finding its square root. So if I find the square root of this side, I have to find the square root of this side as well. So when I do that, that cancels out, oops, I didn't mean that one. That will cancel out the square root and the 2. They cancel each other out. So when I do find the square root of 53, I end up with a decimal. And that's going to be okay. We're just going to round it to 2 decimal places. So the square root of 53 gives us 7.28 inches. And that will be our value for C. So this length here is approximately 7.28 inches long. And then I'm just going to turn it around because I prefer my variable to be first. And then circle my answer. Okay? All right, let's go to the next page. All right, find the missing side. Again, all right, so this time we just have a different side that's missing. So once again, we're going to identify who our A, who our B and who our C is. I always like to start with C. So C is across from my right angle, so this time my C is 8. So we have our C value. Now it doesn't matter which one is A or B. Right? I just happen to call this one A, and I called this one B. But you could have called this A and this B. You will get the same answer either way. All right, so now we will start with our formula. A squared plus B squared equals C squared. And then we can plug in our values. We don't know what A is. That's the one we're going to have to find. We know that B is 5, and we know C is 8. So I'm going to substitute in those values. All right, now I can evaluate my two squares. So we get A squared plus 25 equals 64. Now I have an equation to solve. I need to isolate my A squared. So I'm going to subtract 25 from both sides. And when I do that, that will cancel out these 25s. And we are left with A squared equals 39. All right, so same thing. I now know what A squared is. I want to figure out what the actual value of A is, though. So to do that, we're going to find the square root of both sides. I'm going to take the square root of A squared and the square root of 39. All right, remember, taking the square root of a perfect square of a square means we're just canceling out those. So we're left with A is equal to 6.24. And because these up here are labeled, we have to make sure we label our answer. Since this is 8 feet, 5 feet, then we have to label this one as 6.24 feet. Okay, always label your answers. The values in the problem are labeled, then you have to label your answers as well. All right, now, one more type of problem, and then you can do your try on your own. So this time, we're going to use the Pythagorean theorem to determine if the triangle that they've given us here, these sides here, are actually that of a right triangle. So here they've given us the sides 48 feet, 60 feet, and 78 feet. So again, we can use our Pythagorean theorem, but this time we have all three numbers. So what we're going to do first is identify who is who. So if we remember from the first page, we said that our hypotenuse is always the longest side. So in this case, that's 78. So that's going to be my C. When it comes to these two, doesn't matter which one is which. I'm just going to label them as A and B. All right, so now I'm going to take all three values and I'm going to substitute them into my formula. And what we're looking for is to see, is the value of 48 squared plus 60 squared actually equal to the value of 78 squared? So let's go through and evaluate each of these first. So 48 squared is 2,304, 60 squared is 3,600, and 78 squared is 6,084. So what we're looking for is if these two here will add up to 6,084. So we add them up and we find that 2,004 plus 3,600 is equal to 5,904. These two values are not equal. So I put an equal sign with a slash through it. All right, so because these two values are not equal, then these are not the sides of a right triangle. Okay? So these two values here would have to be equal in order for these to be the sides of a right triangle. All right, so that is the end of our notes. Your task is to complete the try on your own before next class. All right, I will see you then.